Hello and good morning, CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP Switch course, and this morning's video tutorial is going to be on the Cisco Learning Labs curriculum, excuse me, Discovery Activity number 15, where we're going to configure VRRP, and we're going to take a look at some of the differences between the Virtual Router Redundancy Protocol and HSRP, or Cisco's proprietary HSRP. So again, this is a nice, easy sort of introduction into VRRP, which again, let's go ahead and recap. So VRRP is an open standard. It's defined in RFC, originally defined in RFC 2338. I've actually got the original RFC here. So let's think of it as 2338. This would have been VRRP version 1, and then it was obsoleted by 3768. So if I click on 3768, you can see we've got another definition of VRRP here from back in April 2004. And that version, we'll go ahead and say that 3768 is version 2. And then if we take a look at 5798, so this was from March 2010, and this is the most recent RFC, and you can see it's VRRP version 3 for IPv4 and IPv6, and they actually provide sort of a nice little background right here that it says it was based on VRRP version 2 for IPv4, and again, version 2 was IPv4 only, and we've got VRRP specifies the election of what they call the virtual router master and the virtual router backup. But again, RFC 5798 is the most recent RFC, and this is probably the version of VRRP you're going to want to be running. And we'll take a look at that here as we work through this exercise. But again, this is a fantastic document to read through. Let's see if it talks about the virtual router. Yeah, so you can see here it gives you all of the sort of standard features. Now again, remember, we'll talk about the timer values, that it doesn't actually allow you to set the timers to milliseconds, or I should say that milliseconds really isn't outlined in the standard. However, just like spanning tree protocol, remember we talked about the legacy 802.1d and how Cisco took that, they sort of added their secret sauce in there, and then they came out with PVST and PVST+. And it's something very similar here. Cisco supports VRRP, no problem at all. You've got full backwards compatibility with other vendors who are running VRRP. But one of the things Cisco did do as a little bonus was that they added in the functionality to have timers at the millisecond level. All right, so let's go ahead and jump in here. The first step, we're just basically going to configure Ethernet 01 on R1. This is very similar to Discovery 14, where we set up HSRP. So if I were to say show run interface Ethernet 01, you can see we've got a blank interface here, basically nothing set up. So let's go into global config and hit interface Ethernet 01 up. And we're going to start out with IP address 192.168.1, and they have us use .3. And the reason they're going to have us use .3 is because it's very common that you would use .1 as the virtual or the floating router IP. And in fact, let's do this. So you don't have to use .1. In fact, let me show you that the virtual IP, we could pick any IP we want. So I'm going to say for router 1, the IP address is going to be 192.168.1.1. And we're going to be a /24 here. All right. So it was kind of interesting. I kind of chuckled when I first pulled up this discovery activity. It says, spot the differences from HSRP. Well, the very first difference is instead of saying standby and then giving the group number, we say VRRP. So this is a dead giveaway right here that we are not running HSRP. We're running VRRP. And now let's put in our virtual IP address. And again, this is the IP address that will be shared between router 1 and router 2. And whomever has the higher priority is going to be the virtual router master and will be advertising not only the MAC address, but also will be responding to any requests for this virtual IP. So we're going to say VRRP1 IP, and I'm going to use 192.168.1.254. So I'm picking the last assignable IP address in that /24 range, and I actually prefer to use 254 instead of .1. All right, so those two, or I should say the single command that we've run there for VRRP right now is very similar, right? Remember, all we did before was we said standby 1, and then we could set the priority. We were setting preempt. Now this is interesting, right? So VRRP preemption is actually enabled by default. So there's no need to say standby 1 preempt or VRRP 1 preempt. Preemption is enabled by default. So the command standby IP 192.168.1.254. So that command right there is equivalent to the command that we just entered in up here, except for HSRP. All right, so let's go ahead and pull this back. So that's the first command that we've got entered in here. And again, the concept is the same, is that we have a virtual IP that floats between router 1 and router 2. So let's come over to router 2. And we're going to go into global config. Let's say do show run interface Ethernet 01. As you can see, again, in a blank interface here. So let's hop on in here and say IP address, and we're going to use 192.168.1.2. And again, it's in the same subnet. And we've got our VRRP 1 IP, and we're going to say 192.168.1.254. Again, we give a physical IP address, or we give an IP address to the physical interface, and then on both routers we define the same virtual IP that's going to be shared between the two of them. So at this point, let's say do show VRRP. And you can see the state machine here, it goes from init to backup, and then we transition group 1 state backup to master. And so you're probably wondering, well, hold on a second, we haven't configured a priority. So by default, the priority value is the same default value as it is with HSRP. The default value is 100 right here. Now, just like HSRP, if we have a tie, then we're going to be looking to the highest IP address. Let's change the color here. Let's go yellow. Kind of stands out a little bit better. So the state is master, right? Here is my virtual IP address. Now let's take a look. Virtual MAC address. So the virtual MAC address is a little different than the MAC address we were dealing with HSRP, but not much. So again, the first 4 hex characters are all zeros, and here we've got 5 echo 00. We had 0 Charlie 07 with HSRP, and then it's 0101, and with HSRP we had AC, and again those last 2 hex characters are going to be the group number, right? So our group number is 01, so there is the group number. Now, another minor difference here, take a look at the advertisement interval for the hello packets for VRRP. Now, the advertisement interval is 1 second. And remember, the standard dictated, and I would have to check actually to see if in the latest standard as to whether or not, let's see here, millisecond. Let's see if it finds that. No, millisecond. Yeah, not found. So at least the word millisecond is not in here. Let's take a look at timers. Okay, so here we go. So let's take a look at the timers. Protocol state machine, right? So we go into section 6.2, and let's see. And there's the state transition. Remember, we just saw from backup to master and initialize to backup. So yeah, it doesn't look like there's any mention whatsoever of, and there's only 2 matches on timers, and that is it. Let's see, what about hello? Maybe that's a more appropriate thing to be searching for, although the timers should match that. Sending and receiving VRRP packets. What do we have here? Let's see what we've got. Yeah, so again, the standard does not call out milliseconds, but Cisco took VRRP, took the standard that we see here in RFC 5798, added their secret sauce to it, and we can do millisecond timers. All right. So and there's that state machine we were just talking about, right? From master to backup here on router 1. And again, very sort of simple approach, right? You go from init to backup, backup to master, master to init. There's only those 3 states with VRRP. There were more states with HSRP. Excuse me. Okay, so back over here on R2, we can see our priority is 100, and there we go, preemption enabled. And we didn't actually type anything in, so we're good. Now, what is the downtime? Remember with HSRP, we had a setup where it was every 3 seconds for the hellos, and the dead timer basically said 10 seconds. So after 10 seconds, if I haven't received any hellos, or in other words, if I've missed 3 hellos, then I transition to the down state. However, with HSRP, it's, and you can see here, it's funny, it kind of puts in that 3.609. So it's 1 second for the hellos, and the dead timer is 3 times the hello value. So in here, it's 3.609, right? Okay. So those are some of the minor differences between HSRP and VRRP. And again, just like you can say show standby, I could actually say do show VRRP and brief, just like we could say show standby brief. And we get pretty much the same output, same format, very, very close. Gives us the master address, shows the group address, which is actually that virtual IP that we're using right now, which is 254. All right, so step 3, right? It wants us to go ahead and on router 2, we're going to set the priority. Now, remember that the default priority is 100. And what's going to happen is that the router with the highest IP address would scoop that up if, in fact, we had a tie. So what we're going to do here is we're going to say VRRP, and we're going to set the priority for group 1. And what are the values we can set it to? It's 1 to 254. So let's go ahead. We'll spice this up a little bit. We'll say 250. So basically all we're doing here on router 2 is ensuring that router 2 is going to be the virtual routing or virtual router master. So if I transition back over here to router 1 and say show VRRP brief, so here's the output for that. You can see what is my state. I'm the virtual router backup. The master, virtual router master IP is 192.168.1.2. And again, there's my virtual IP. Preemption, yes, preemption is enabled by default. And here's the priority for router 1. If I were to say show VRRP, we get a little bit more information here, right? We see the VRRP MAC address and the same information that we saw previously, with the exception that router 1 is the backup. On router 2 is the master. Okay, so now we're going to talk a little bit about authentication, right? So VRRP and authentication. And although we didn't get into this with the HSRP, we certainly do when we hit the Netacad Lab 6.1 tomorrow night. So remember that VRRP by default is going to use plain text for its authentication. However, we can also configure it to do authentication via MD5. And so Cisco, and what it says here is the VRRP standard used to specify plain text and MD5, which was later revoked. However, Cisco, right, remember they add their secret sauce in, Cisco continues to support those authentication messages, right, or methods. So VRRP came out with MD5 in 2338 and RFC 2338, and then it removed support for those those authentication methods in RFC 3768 and 5798. So again, Cisco still supports the authentication plain text and MD5 that was outlined in RFC 2338. So here's what we're going to do. We're going to go ahead, and it looks like it wants us to set up MD5 authentication here on router 1 and router 2. So I'm on, let's see, step 5 if you're following along. So on router 1, let's go into global config and let's say interface Ethernet 01, and we're simply going to say VRRP1. If I do a question mark, you can see authentication, right? So I can even put in a description here, and we've got up to 80 characters, and I'm not sure if we have to put it in quotes, but we probably don't. So let's just go ahead and say this is my this is my VRRP group configured 319.2016 and TP bond fee. There we go. So we'll throw a quick description in there, and then we'll say, actually bring this back. So VRRP1 and authentication is what we're interested in. So again, you can see here we've got plain text and use MD5 authentication. We're interested in the MD5, and we're going to say the key string. And actually, if I back up a little bit here and do a question mark, you can see we could actually create a key chain. Now, the difference between a key string and a key chain is that a key chain can contain multiple keys, which are your key strings, right? And we can actually set lifetimes on those keys. And this is very similar to when we were doing OSPF authentication, when we would use a key chain and then define individual keys that had different strings, different key strings underneath that key chain. So this is just simply showing us we're going to use the key string, and we just type in whatever we want the key string to be. And so we'll just say VRRP. Right? So as soon as I configure that, and exactly, there you go. So now we're going to start seeing syslog messages that are telling us bad authentication. And the reason it says from 192.168.1.2 is because they're not set up to do MD5 authentication. So from R1, from router 1's perspective, and you can see we've got these types, right? So type 0 was what we saw up here earlier, that plain text authentication, right? So it's expecting type 254. So what we can infer from this is that type 0 is no authentication at all, right? And MD5 authentication is going to be 254, type 254. So let's go ahead and sort this out. They want us to cruise over to the other router. But before we do that, let's say do show VRRP brief. And you can see that now router 1 believes that he is the master, right? Let's see what router 2 thinks. So come over here on router 2 and say do show VRRP brief. And router 2 thinks he's the master. And they both think that they own that IP address right there. So if I come back to the diagram, right now both of these guys think they own that IP and MAC. So let's go to the access layer switch 1 and go into privilege exec and say show MAC address table. And you can see here that it should go out Ethernet 01. Right? Now, what just happened? So you can see the problem here, right? So this is what we call flapping, where both of them, it's kind of like a split brain scenario. So here is, and we're on the same access layer switch. So 1 minute the access layer switch says, yep, I need to go out Ethernet 01 to get to that MAC address, which goes to that .254 virtual IP. And then a second later, take a look at what happens. Same MAC address, but now the access layer switch says, no, go out Ethernet 02 to get there. So what's happening? We have a split brain scenario where router 1 thinks he is the master, and this is access layer 1. And router 2 believes that he is also the virtual router master. And so they're both fighting right now and both advertising that, hey, no, I am the one advertising that MAC address. So this access layer switch is going to continue to thrash back and forth saying, okay, right, to get to the virtual router master, we go out Ethernet 01. No, 02, 02, and then it's going to flip back to 01. And so that's what's going on, because that virtual IP, because authentication is broke, both of these guys are saying that they are in charge of that virtual IP, and that's not the case. So definitely something to be aware of if you're thinking about implementing authentication sort of after the fact. So if we watch here, you can see it's 0202, 01, 01, 02, 02, 01, 01. And so, excuse me, this is going to go on until we fix things here. So let's take care of that. Let's come over here. And actually, if I were to come down to, where's my job aids? So same address, 192.168.4.22. So same address from the previous exercise. So let's come down here to PC1. And let's see what happens. And I'm not going to ping it a million times. We're not going to lock it up this time. If we were to say 192.168.4.22. And let's see what happens here. So we get success, right? And we're going to get success because it's kind of going back and forth. But now if I were to say repeat, and we'll just put in, we'll do 10,000. So you can see it's going to continue to ping, right? But it's flipping back and forth the entire time. So good news in the sense that if it was to go down, right, you can see here that if it did switch over legitimately, that we would be in good shape. However, what we don't want is for things to be flipping back and forth. So let's come over here to router 2. Excuse me. I think we're in Ethernet 01, but we'll double check here. So we're going to say VRRP 1 authentication MD5 keystring, and I think we use VRRP. So now let's see what happens here when we say show VRRP. Right? So I show that I am the master. And let's see, did that sort things out over here with router 1? When I say end, and we say show VRRP. And he is the backup, right? So we've solved the issue with the flapping. And also, what's one of the things we catch here? Authentication is MD5 key string, right? So it's also telling us that authentication has been configured. And so again, the Learning Labs activities, phenomenal activities to kind of ease you into the configuration, point out some of the minor differences between Cisco's HSRP and the IEEE, sorry, I shouldn't say the IEEE, sorry, the RFC 5768, or 5798, RFC 5798, VRRP version 3. Okay. If I were to say, let's kick something off here. I want to do, because the question that's bugging me is, how do you know what version of VRRP you are running? So if I was to say, show VRRP interface Ethernet 01, no, that's just going to give me the basic information there, which is why I'm thinking I want to see a debug of VRRP, and let's do all. We'll just debug everything and see what we get here. So you can see that we are getting the hash, it looks like, the received hash. We're getting the group information. I was hoping to see some version information here, and I don't see any version information coming in the debug. So let's say you all and kill the debug. But again, when we debugged everything, you can absolutely see that group 1 advertisement showing us who the master, or I should say who the virtual router master is going to be. And doesn't show us any of that information in here. If I were to say, let's go into interface, let's see if we can do this. Interface Ethernet 01, and maybe just like with HSRP where you can set the version, maybe we can set the version here. And it does not appear that it's going to let us do that. Track timers. And actually, if we were to take a look at timers, you could see that there's the millisecond argument. And so this is where I was saying that Cisco actually supports that millisecond functionality, whereas the standard doesn't specifically define it. And that's okay, right? Because, again, Cisco took the standard, they throw their secret sauce in there, and they're good to go. So let's see. That is everything. That is everything. All right, so this is going to wrap up Discovery Activity number 15. We've taken a look so far at HSRP as well as VRRP. We took a look at the differences. And again, once we get into the NetAcad Labs, it's going to be a much deeper dive with far more features and functionality being enabled. All right, well, this wraps it up, and I will see you guys tomorrow night. Enjoy the rest of your weekend.